You know that picture of the black hole in M87? Talk about going viral. It really makes you think about just how powerful these things are.
Oh.
But what if I told you that there might be black holes out there older than stars?
That's where the idea of primordial black holes come in. They're these hypothetical objects that formed right after the Big Bang, like fractions of a second after the universe began.
So for this deep dive, we're going to try to wrap our heads around primordial black holes, and we're using the History of the Universe YouTube video to help us. We're going to look at some pretty crazy questions like, could these primordial black holes be what supermassive black holes come from? You know, the ones at the center of galaxies.
Yeah.
Could they explain dark matter? And how do scientists even start to look for something that old and that small?
Yeah. So to get what's so important about primordial black holes, we have to take a step back and think about how normal black holes form.
Okay, so Black Holes 101. Give me the basics.
So usually we think of black holes forming when a huge star dies. It collapses in on itself, and all that mass gets squeezed into this tiny space.
But it's not just about size, right? It's about density.
Exactly. The denser something is, the stronger its gravity is going to be. And when a dying star collapses, its density just explodes, and it makes this region where gravity is so strong that nothing can escape, not even light.
So when we see pictures of black holes, like that one from M87, what we're really seeing is the shadow of the event horizon, that point of no return.
Precisely, like a drain in space, pulling everything in that gets too close. Now imagine that density, but on a scale that's almost impossible to imagine.
Wait, denser than a dying star? How?
All right, get ready, because this is where things get really in. So we've got these normal stellar black holes, but then there are the supermassive ones, millions or even billions of times the mass of our sun.
And these supermassive black holes are found at the center of most galaxies, including our own Milky Way, where Sagittarius A is. But how did they get so big so fast?
That is the question. The usual way we think black holes form has a really hard time explaining how these supermassive black holes got so big so early in the universe.
It's like finding a skyscraper in a ghost town. This doesn't make sense.
That's a great way to put it. And that difference is one of the reasons why Stephen Hawking's idea of primordial black holes is so interesting. He said that these black holes didn't come from dying stars, but from the crazy conditions of the Big Bang.
Okay, so I'm trying to picture this.
Yeah.
The universe is barely a second old, everything is super hot and dense, and somehow black holes are popping into existence.
Imagine the entire mass of the Earth squeezed into a tennis ball. That's how dense we think primordial black holes were.
So during the Big Bang, some parts of the universe were so dense that they just collapsed into these tiny black holes.
Yeah, that's the idea. These dense spots were like seeds scattered throughout the early universe, each one with the potential to become something huge.
It's like the universe was filled with these little monsters from the very beginning. But how do we even begin to find them? They're ancient, they could be tiny. It's like looking for a needle in a haystack, but in space.
Yeah, you're right. It's a huge challenge. But scientists are clever, and they've thought of some very smart ways to try to find them.
Okay, tell me, how are we trying to track down these hidden primordial black holes?
One way is to look for Hawking radiation. You see, black holes aren't totally black. They actually radiate a little bit of energy because of quantum effects near the event horizon.
Wait a minute. I thought nothing escapes a black hole. How can it radiate anything?
It's a tough concept, I know. But in the quantum world, things get a bit fuzzy. Particles and antiparticles are constantly popping in and out of existence near the event horizon. Sometimes, one of those particles falls into the black hole while the other escapes. That escaping particle takes away a tiny bit of the black hole's energy.
So black holes slowly disappear over time.
Exact. And the smaller the black hole is, the faster it evaporates. Eventually, it should shrink down to a point where it explodes in a burst of energy, a gamma ray burst. If we can detect these bursts, they might be primordial black holes evaporating away.
So we're searching for tiny fireworks displays across the universe.
You can say that.
That's so cool. What are some other ways that scientists are trying to find primordial black holes?
Another way is to use gravity. Remember how we talked about black holes warping space-time? Well, that warping can act like a lens, bending and magnifying light from stuff behind it.
Oh, gravitational lensing. So if a primordial black hole goes in front of a distant star, we might see that star's light flicker or get brighter for a second.
Exactly. And by looking at these lensing events, scientists can figure out how massive the object doing the lensing. If we find lensing events that fit the expected mass of primordial black holes, that's another clue.
So we're basically turning the universe into a giant magnifying glass to hunt for these little black holes. What else?
Well, there's also the chance of finding them using gravitational wave. When black holes crash into each other, they send out ripples through space-time, and these ripples can be picked up by things like LIGO.
Right. The LIGO Observatory detected the first gravitational waves a few years back, which proved what Einstein said about these ripples.
And those discoveries opened up a whole new way to see the universe. Now, scientists are looking for gravitational wave signals that might match what we expect to see from primordial black holes merging. It's like listening for echoes from ancient collisions in space.
So we've got Hawking radiation, gravitational lensing, gravitational waves. Are there any other tricks?
One more, and it involves looking way back to the beginning of the universe, the cosmic microwave background radiation.
The cosmic microwave background, that's like the afterglow of the Big Bang, right?
Exactly. It's a faint echo of the energy from those first moments of the universe, and it has a lot of information about the early universe. If there were a lot of primordial black holes, they would have left a mark on this radiation.
So scientists are searching this baby picture of the universe for any sign of primordial black holes.
Yep. It's a really careful process, but it could give us big clues about the early universe and how primordial black holes affected its evolution.
Okay, so we've got all these different ways to try to find primordial black holes, but have we actually found any real evidence?
That's where things get a little complicated. The evidence so far is still up in the air. We've ruled out certain sizes for primordial black holes based on some of our observations, but there's no definitive proof.
So it's a cosmic mystery still in progress.
Exactly. But that's what makes it so exciting. We're looking for something incredible, and the answers could completely change how we understand the universe.
Well, let's take a deeper look at the evidence. What have we learned so far, and what are some of the most interesting hints that primordial black holes might really be out there?
So one of the most interesting things about primordial black holes is that they might be connected to dark matter.
Oh, right, dark matter. That mysterious stuff that we can't see that makes up a huge part of the universe.
Exactly. It's kind of a puzzle. We know it's there because of its gravity, how it affects galaxies and stars, but it doesn't interact with light or any other kind of radiation, so we can't see it.
So how do scientists even begin to figure out what dark matter is? It seems impossible.
Well, there are a couple of main ideas. Some think dark matter is made of these theoretical particles called WIMPs. That stands for Weakly Interacting Massive Particles.
Okay.
These particles would mostly just interact with the universe through gravity, which makes them really hard to detect.
And then there's the macho theory. Massive, astrophysical, compact halo objects.
Right. Machos would be things like brown dwarfs, neutron stars, or black holes that are just too dim for us to see.
And Stephen Hawking thought that primordial black holes could be a type of macho. Right.
Yeah, he was one of the first to suggest that these ancient black holes all over the universe could be some or even all of the dark matter.
So these tiny black holes from the Big Bang could be holding galaxies together. That's wild. But if they're so hard to find, how can we tell if primordial black holes are really what dark matter is made of?
That's a great question. It's tough, but there are a few ways we can try. One is to look for any damage that primordial black holes might cause.
Damage? Black holes are scary enough already. What could they possibly destroy that would give them away?
Okay, so picture this. A primordial black hole runs into a neutron star or a white dwarf. Those are the super dense leftovers of dead stars.
All right, I'm picturing it.
Now, even a small primordial black hole would have crazy strong gravity. If it got close to one of these dead stars, it would basically rip it apart.
Whoa, so by searching for these missing stars, we could figure out if there's a primordial black hole out there.
Exactly. It's like searching for crumbs around a hungry monster.
I like that. But has this method actually found anything?
Not really. Just like trying to find Hawking radiation, we haven't found any solid proof.
Yeah.
It seems like these primordial black holes are really good at hiding. But there's another thing we can check, the cosmic microwave background radiation.
Right, the baby picture of the universe. We talked about that earlier. If there were a lot of primordial black holes in the early universe, they should have left some kind of mark on that radiation.
That's what we think. And scientists have looked at this radiation very, very carefully, looking for anything unusual that could point to primordial.
And did they find anything, any sign of our black holes in that baby picture?
The results are interesting, but it's not a clear yes or no. Some studies say that primordial black holes of certain sizes couldn't be a big part of dark matter, but other sizes are still possible.
Okay, so we've ruled out some things, but not everything. But wait a minute. Earlier we talked about LIGO detecting those merging black holes. Didn't that make scientists think about primordial black holes?
It definitely did. The black holes that LIGO found were each about 30 times the mass of our sun, which is strange. because black holes made from collapsing stars usually aren't that massive.
So too big for stellar black holes, but too small to be supermassive ones. That does leave a pretty small space for primordial black holes to fit in.
Exactly. And it gets even more interesting. When scientists figured out how often primordial black holes of that mass would theoretically crash into each other, it matched pretty well with how often LIGO was detecting these mergers.
Okay, that sounds promising. Is this the proof we've been waiting for? Have we finally confirmed that primordial black holes exist?
Not so fast. While it's an interesting clue, it's not a guarantee. Scientists are still talking about where those merging black holes came from, and there are other explanations besides primordial black holes.
Science is never a simple yes or no, is it? It's more like constantly trying to get a clearer picture.
Exactly. But what LIGO found has definitely made people more interested in looking for primordial black holes. It's a big piece of the puzzle, and it's making scientists think of new ways to look for them.
So what happens now? What are the next steps to figure out this cosmic mystery?
Well, for one thing, scientists are building new and better tools to look at the universe using all sorts of radiation. They're also working on simulations to try to understand how primordial black holes behave and how they could affect things.
And don't forget about the James Webb Space Telescope. It's giving us incredible views of the early universe, which could give us clues about primordial black holes.
Absolutely. The James Webb Telescope is a game changer. And there's another mission in the works called LISA, the Laser Interferometer Space Antenna. LISA will be a space-based gravitational wave detector. So instead of being on Earth like LIGO, it'll be out in space going around the sun.
Ah, I see. So by being away from all the noise on Earth, LISA will be able to detect even fainter gravitation.
Right. This means LISA can pick up signals from events that are too quiet for LIGO to hear, like when smaller black holes merge, maybe even ones from the early universe.
It feels like we're close to a major breakthrough. With all these new tools and ideas, it seems like it's only a matter of time before we understand primordial black holes.
It's a really exciting time to be studying the universe. Who knows what else we'll find?
Okay, before we get lost in the future, let's just appreciate how far we've come. We started with this crazy idea of black holes forming at the same time as the universe, talked about how they might explain dark matter, and even considered the possibility of one being in our solar system.
It's pretty amazing, isn't it? It shows how curious humans are and how much we want to understand the universe. And it reminds us that even the craziest ideas can sometimes be true.
Speaking of crazy ideas, there's one more thing about primordial black holes that we should talk about, and it's a little closer to home.
Ah, yes. You're talking about Planet 9 and the possibility that it could actually be a primordial black hole hanging out at the edge of our solar system.
Right. We've talked about these ancient black holes maybe affecting whole galaxies, but to think that there might be one right here in our neighborhood, that's incredible.
It's a really cool idea, right? Let's explore that a bit more.
Right. My mind is officially blown. A primordial black hole just hanging out in our solar system. That's straight out of a sci-fi movie. But let's start at the beginning. What exactly is this Planet 9, and why do scientists think it might even be out there?
Well, it all started with noticing some strange orbits in the Kuiper Belt, that area beyond Neptune that's full of icy objects. Some of them have these really weird orbits, like they're stretched out and tilted in ways that we can't really explain with our current models of the solar system.
So it's like something out there is messing with their gravity.
Yeah, exactly. And the main theory is that there's a hidden planet out there, this Planet 9. It's thought to be about 6 times the mass of Earth and orbiting way farther out than we are, like hundreds of times farther.
That's huge. But if it's that big, how haven't we seen it yet?
That's a thing. It's also really, really far away. Because it's so distant and small, it would be super faint, too faint for our telescopes to see.
Okay, that makes sense. It's like trying to see a tiny bug in a dark forest from miles away. But this is where the primordial black hole idea comes in, right?
Right. So some scientists have said, what if Planet 9 isn't a planet at all, but a primordial black hole with the same mass?
Wait, a black hole the same mass as a planet? Wouldn't that be, well, massive?
Not really. It all comes back to density, not size. A black hole with that same mass would be incredibly tiny. We're talking about the event horizon, that point of no return being like the size of a tennis ball.
A tennis ball-sized black hole, just out there in our solar system. It's both kind of scary and really cool. But if it's that small, wouldn't it be even harder to find than a planet?
You'd think so, right? But here's the interesting part. A black hole that small wouldn't reflect any light, making it basically invisible. And that might be why we haven't found Planet 9 yet. It could be too faint for us to see, even if it was a planet.
So maybe we've been looking for the wrong thing this whole time. It's like searching for a lamp when we should be looking for a tiny hole in space. But wait, even if we can't see it, wouldn't a black hole still have gravity and affect things around it? Like, wouldn't we still see those weird orbits in the Kuiper belt?
Absolutely. The gravity would be the same whether it's a planet or a black hole. That's why scientists thought of the Planet 9 idea in the first place. The tricky part is figuring out if it's a planet or a black hole that's causing all those gravitational effects.
Okay, so how do you even start looking for a tennis ball-sized black hole in space? It seems impossible.
It's definitely a challenge, but scientists have a few ideas. One is to look for something called gravitational lensing.
Right, we talked about that earlier. A black hole's gravity bends space-time, which bends light from objects behind it. So if this black hole passed in front of a distant star, we might see a little flicker or brightening of that star's light.
Yep. And by studying these lensing events, we can try to figure out the mass of the object causing the lens. If it matches what we'd expect for Planet 9, whether it's a planet or a black hole, that would be a big clue.
So we're basically using the universe as a giant magnifying glass. What else?
Another possibility is to look for dark matter building up around the black hole.
Wait, dark matter gathering around a black hole? But we can't even see dark matter. How would we see that?
We can't see dark matter directly, but we know it's there because of its gravity. The idea is that the black hole's gravity would pull in dark matter, making a sort of halo around.
Okay, I think I'm getting it. So this dark matter halo, even though it's invisible, would still have its own gravity, which we could then detect.
Exactly. And some scientists think that when the dark matter in that halo interacts with itself and the black hole, it might give off a tiny amount of radiation that we could maybe pick up with super sensitivity.
That's fascinating. So it's not completely hopeless. We might be able to find this black hole because of how it affects light or dark matter.
And there's always the off chance of detecting Hawking radiation, though for a black hole that small, the radiation would be so faint it'd be really tough to separate it from all the background noise.
Okay, so a long shot, but still a possibility. But let's say, just for fun, that we do find a primordial black hole way out there in our solar system. What would that mean for how we understand the universe?
It would be a huge discovery. It would be the first real proof that these ancient objects actually exist, confirming what Stephen Hawking thought up all those years ago. It would also give us a chance to study a black hole up close, which could tell us new things about gravity and how the universe has changed over time.
And what if, after all this searching, Planet 9 turns out to just be a normal planet, not a black hole? Would that be disappointing?
Not at all. Finding a new planet in our solar system would be amazing. It would help us understand how planets form and the history of our own corner of the universe.
So no matter what we find, the search for Planet 9 is helping us learn and pushing us to explore in new ways.
I completely agree. It really shows how curious we are and how much we want to figure out the universe. And who knows what other surprises are out there waiting for us to find them.
This whole deep dive has been a wild ride. We started with this mind-boggling idea of primordial black holes forming at the very beginning of everything. Talked about how they might explain what dark matter is, and even considered the possibility of one being right here in our own solar system.
Yeah, trying to find these elusive objects has really taken us to the edge of what we know, pushing the boundaries of astronomy and physics. And even though we might not have all the answers yet, the search itself has been incredible.
It's like we've been on this cosmic treasure hunt, following clues that lead us further and further into the universe.
And the best part is, this is just the beginning. With new telescopes, new ways of looking at things, and tons of curious scientists out there, who knows what incredible things we'll find next.
So well said. Keep looking up, keep asking questions, and never stop exploring. The universe is full of amazing things just waiting to be discovered. Until next time, happy deep dive.